Welcome to Digital Toolbox. In this video we're just going to go over the basics of lighting and how lights are understood in 3D programs, specifically 3DS, and how that's different from lighting in real life. So here I have a basic light, this little kind of diamond shaped thing. It's an omnidirectional light, so it's really just a little ball of light, and I can drag it around my scene. So there's a few key points to notice about lighting a 3D model. There aren't any shadows here by default, so notice I can take this around and move it up and down, and these objects aren't casting shadows. So you can have it cast shadows. It's done per light, but you have to tell it to cast shadows, and that's going to add to your rendering time. So you want to make sure that your select shadows to be cast exactly when you need them, and don't have them turned on when you don't need them, to take into consideration your rendering times. Another thing is how it calculates. Just takes a ray from this object, specifically this omnidirectional light, and it'll trace it to these other faces in the scene. So if it's right here, it's hitting all these faces and at different angles and things like that. So if it sees that face and hits it, it'll light it. If it doesn't, it won't. So move my light around. You can see a few things like the incident angle is a big deal. So here I have a kind of gray base layer down there, base plane, and if my light's really low to it, it's casting it right below it, and then it kind of falls off, and then the higher up I go, that incident angle is less and less, or there's more and more area for it, so more of it gets light. One last goofy thing about lighting in the computer is that there isn't a fall off by default. So normally if you shine a flashlight in a field, you can see kind of really close to you, and then further away it falls off. Not so in 3D programs. So you can see here that yellow box and the sphere are getting the same amount of light as they are here. Just go ahead and delete this plane, and if I render this right now, there would be no plane down there. There's no surface for the light to bounce off, so there's not going to be anything there. And then you can see that the lighting isn't doing anything. If I pull it back here, it's still getting the same amount of light as it is there. So a few fun, interesting things to think about, but the more you take into account how the computer is actually tracing the rays of light from the lights that you create to the surfaces that you have in the scene, and really trying to maximize the product you get by minimizing the render time and not having in goofy things while you render your scene. So that's about understanding how the computer interprets lights in 3D.